Right, so I call this presentation Programming Ideas, Concepts, Tools, Methodologies, and How to Become a Developer. Methodologies, tools, and how to become a developer are mostly not in this, didn't make it in the slideshow. But this is going to give you maybe a good high-level overview, especially for those people who have like no experience and don't understand the world that programmers inhabit every day. So let's see. Programming is about ideas. So like the main, reason for programs are the main, I guess you could say, why do people write programs in the first place? It's because they have an idea of something they want to accomplish, something they want to achieve that they think a computer can help them with, right? And then what they are trying to accomplish through programming is taking the burden of doing that task and putting it onto a machine, like a computer or some sort of device, right? But it all comes from like you and your own personal inspiration of what could be possible. Like this thing didn't exist or these things didn't exist until somebody came up with some, oh, well, what if it could do this? And then that's, where the genesis of like a programmer's job kind of starts at that point. So like I said, I tried to get programming into 3 simple steps. So like I kind of started with, you begin with a computing problem. And basically a computing problem is a problem that a computer could do, right? So you start kind of, what is your goal? What problems do you want to solve? What do you want to be able to do? For some of you, it might be building websites. For other of you, you might want to make your coffee maker work with your phone, Internet of Things. For others, it might be you want to know how a self-driving car works, or you want to become more organized and build things to make your computer do stuff automatically when you're not there. But it all comes from what do you want to do, or what is the computing problem that you want to solve? And this wizard here is named DJ Greenfield. He's somebody who was above me at Turing, and he first introduced me to this concept of dream-driven development. So it's the idea that like when a programmer sits down at the computer, what do? Well, a bad programmer just starts typing random stuff and trying to figure stuff out. A good programmer will think for a little while, maybe map some stuff out, maybe write some stuff down, and then go. A great programmer, or a better programmer, will first write tests. So they'll conceive of situations that should be if their program works. So it's like, if my calculator works, when I add 1 and 1, it should equal 2. So they write out things that might test their ideas, test their concepts, and then they write a program that makes all of those tests pass. And then the very, very, very best developers, they think of the most simple way that they can make an idea work. So let's say, I wanted this microphone to talk. What would I want it to do? I'd just be like, talk. And then the microphone would know exactly what to do. So a dream-driven developer might write the simplest line of code that would be the execution line for a huge program. And then they work backwards from that line to build up the infrastructure that will make that line of code run, right? So it's almost like this idea of you think about the farthest, most, impossible idea that you have, and then you work yourself backwards. Well, how would I make that idea work? And so the working backwards and all that stuff is the second step, which is developing an algorithm. And for the science people here, algorithmic thinking is probably something you're very familiar with. I don't know if there are any knitters here, but my mom knits a lot. But here's a simple algorithm for how to put the thread through the needle when you're knitting. But an algorithm is like a recipe or any series of instructions, series of a process that can be broken down into discrete steps, right? So in programming, they often you often get stuck. You often reach a problem that you've never seen before and a set of constraints you've never worked with before, right? So usually, and this is a common thing at Turing, Rob will tell you, that they always say if you get stuck, if you don't understand the problem you're trying to solve is too big. So algorithms help you take huge ideas like websites and apps and Facebook, and they help you start, okay, what is the thing that I immediately need to do now in order to make the next little piece of this thing work? And that way of thinking and breaking things down into steps is a huge, huge part of programming. Before you even type any code, before you even write a line of code into your computer, you already should understand where you're going, what the problem is, and what you hope to achieve when you reach your goal. So the last step is you translate your algorithm into executable computer code, and that is where like the knowledge of a developer comes in. So different languages are good at different things. You might want to, decide, and people talk a lot about the stack or full stack JavaScript, but really all that's saying is what languages are you going to use for each piece of the program? How are you going to display stuff on the screen? How are you going to make queries to the database? So it's important when you're translating your algorithm, you not only have to think of how do I write this statement, but also what are my technological constraints? Will 1,000 users be using this site? Will 1,000,000 users be using this site? How will users interact with the program? Are they going to be constantly liking and unliking and doing all these things that are going to require tons of frequent interactions with your database? Or are they going to be on your site, watching videos or streaming things? So when you translate your idea into something like a computer program, you want to really think about these types of constraints. And then the strategy that I've always been taught is, since a program is a huge complex thing, the first version of a program you write is not going to be beautiful. It's going to be hideous, actually. But the philosophy that you should do, and especially when you're learning on your own, is just make something work and then make it better. If you can get a program that runs, even if it takes an hour to run, it runs, it works. It's better than a program that doesn't work, that might, if these things were to happen, be better than your program. So it's kind of this idea that you want to sort of map out your steps, break each step down, and then make some little component work, make it work and test it, and then as you build the program, you'll improve that as needed. So again, this was that's a corny joke. But yeah, so any questions so far on the 3 steps? So, the way that at least I've been taught for web development, it's, define a computing problem, come up with an algorithm, translate your algorithm into computer code. And that's it, you're programmers. So it's that easy.